All right, today we're going to talk about sequences in series. First off, some objectives we're going to have today to find specific terms of a sequence given the nth term of specific term in the sequence. And then we're going to use sigma notation. We'll talk about what that is. First off, a sequence, and you guys have all seen sequences before, but a sequence is an ordered set of numbers. So we have different general terms, and this is considered like our rule for this specific sequence. The sequence of numbers will follow that rule. And so given that general term of the sequence, find the first three terms and then the 12th term of the following sequence. So the n is standing for the type of term it is. So for finding the first term, we are just going to be able to plug in the number 1 in for n and find out that our first term is equal to -1. And then we could do the same thing for plugging in the second term. We're going to plug in 2 for our n value and find out that our second term is equal to 1. We could do the same thing for the third term and the 12th term. First off, plug in 3 in for n, and then for the 12th term we would plug in 12 for n. So when we simplify that, we can find out that the third term is equal to 3, and the 12th term is equal to 100. I'm sorry, not equal to 21. So why don't you guys go ahead and pause the video and do the next one here for letter B. So when you plug in for the first term, we're going to plug in 1 for n, so it's to the first power and times 1 squared. So that's going to be -1 times 1, gives us a value of -1. And then when we plug in for the second term, still going to be -1, but this time it's to the second power and then 2 squared. So this is going to be +1 times 4, they're giving us a value of 4. And when we do it for the third term, to the third power and 3 squared, this is going to be -1 to the third power will be -1 times 9, giving us a value of -9. And then for the 12th term, any negative value, or any, -1 to an even power would give us +1, and then times 144 give us a value of 144. We're going to skip that part. And then a series is an indicated sum, so we're going to find the sum of the terms in this specific sequence, and we will dictate how many numbers in the sequence. So it won't be a to the n, it will be maybe like the first 5 terms or etc. And written in sigma notation, this is the notation that is used to find this series, the sum of a sequence of numbers. So in this specific example, this is telling us in letter A to find the sum of the first 3 terms in the sequence. So that means that we can plug in 1 initially and find out that that first term is 3. And then we can plug in for n, we could plug in 2 for the second term. Find out that that is 2.5. And then we need to go up to the third term because it says the first 3 terms, and so we will do 2 plus 1 over 3 for our n value of 3. And find out that that is 2.33, and those are the first 3 terms in the sequence. So we will add up those 3 terms and find out that the sum of those three terms is 7 5/6. We can go ahead and do that for the second one. This time we're finding the sum of the first 4 terms. So we can plug in 1 for n. That is our first term. And then we could add that to find our second term. So it would be 5 to the second power plus 1. And then we'd have to continue to find the third term and the fourth term. So could you please pause the video and find the sum of the first 4 terms in this sequence. So we find the first 4 terms in the sequence. We get 424, 124, and 624, and we find out that the total sum of those terms is 776. That concludes the notes for sequences in series, and we'll see you guys tomorrow.